All right, so in this video, we are going to talk about solving absolute value equations. I might do inequalities in a different video just for time's sake, so it's not like an hour-long video. So what is an absolute value? So you may remember an absolute value is the distance something is away from 0. So if I have 5, 5 is 5 units away from 0. And -5 is also 5 units away from 0. So therefore, an absolute value, if you take the absolute value of any number, you will never get a negative number. Okay? Never. I'm going to put an absolute value will never output a negative number because distance cannot be negative, right? So I cannot go -5 miles to school. It just doesn't work. You don't talk about quantity in the negatives. So you cannot have negative watermelons. You can't have negative miles, negative distance. So, like we just said, the absolute value of 5 is going to be 5. The absolute value of -5 is also going to be 5 because -5 is 5 units away. Now, what happens if the negative is on the outside? Well, just like x, where you have like -1x is the same thing as -x. That -1 doesn't really show up. It comes up as just a negative. So this is really -1 times the absolute value of 5. So this is -1 times the absolute value of 5, which is just 5. So this is -5. The only time you can get a negative outside is when there are things on the outside. Negative as the answer. Same concept here. This is -1 times the absolute value of -5, which is 5, and that is -5. Okay, so what about when we're solving? That's the question. So here you can use logic, right? So the absolute value of x is 5, right? Is equal to 5. Now you can use your logic and say, well, I know that x equals 5 works because the absolute value of 5 is 5. And I know x equals -5 works because the absolute value of -5 is also 5. However, the process is going to be the same for all absolute value equations. If you have the absolute value isolated on one side, you will take whatever's inside of the absolute value and set it equal to, right? So we're going to set it equal to, and you're going to set it equal to that 5 and the negative of it. Okay? So let's look at what that looks like. With this one, right? So I'm taking what's inside of the equation, which is, I'm going to split it, right? Once the absolute value is by itself, I can split, right? Just think about you're taking those absolute value bars and you're splitting them up, okay? You're taking what's inside of the absolute value, which is -x, -x. You're setting it equal to the positive and the negative of this. So 5 and -5. So then I solve. I have two equations to solve. I have divide by -1, divide by -1. And so I get x equals -5 and x equals +5. Yes, you will have two answers because two solutions of x satisfy this equation. Two things make this true, so you have two answers. Now, here's the key. You have to always check your answer because there is something in math called an extraneous solution, which means it is possible to get a solution that actually does not satisfy the equation. Yes, it's possible. So we will see an example of that, but let's just check this equation. So I get negative x is equal to 5. The absolute value of negative x is 5. So the absolute value of negative 5, because that was one of my solutions, is equal to 5. Let's check that. This becomes positive. So the absolute value of 5 is 5, so that is true. And let's check the other one. The absolute value of negative 5 equals 5, so this becomes the absolute value of negative 5 is 5, so 5 equals 5. It is true. So it is important to check your answer. We're golden. Okay, so what about something like this? If I have x plus 40, the absolute value of x plus 40 is equal to negative 100. So I'm going to do the same process. It is already isolated, and we're going to talk about it when it's not isolated. But you see that? So we just split into 2. Now, I'm going to take what's inside of here. Let's go blue. So we have x plus 40, right? So I'm going to go x plus 40 and x plus 40 is equal to, and I want to do the positive and the negative of this number. So I'm going to put 100 and negative 100, right, from this. So let's solve. So I have minus 40 minus 40. And I get x equals 60 and x equals negative 140. Let's check our answers. So I have the absolute value of x plus 40 equals negative 100. If I plug in 60, I get the absolute value of 60 plus 40 equals negative 100. This becomes the absolute value of 100 equals negative 100. 100 equals 100, negative 100. Not true. This does not work. Let's check the other one. Negative 140 plus 40 equals negative 100. Okay, so I have, this becomes the absolute value of negative 100 is equal to negative 100, but this becomes a positive. So both of these are extraneous solutions. Neither one of them work. Okay? It's important to check your answer. Sometimes you will get an answer that does not work. Now, here we can catch that mistake because we know that the absolute value of anything will never ever give a negative. So we know it's going to be an error. But sometimes it's not as obvious. So what about something like this, right? When I have a bunch of fluff on the outside. I need to, again, isolate my absolute value. So I'm the same way if I had 2x plus 7 equals 31, I'm going to subtract the 7, divide by 2, right? So the first thing I'm going to do here is I'm going to subtract this 7. And I get 2 times 3x, the absolute value of 3x, equals 31 minus 7 is 24. Then I divide by 2 to get rid of that coefficient. The absolute value of 3x is equal to 12. Now I have, this is isolated, right? They're by themselves, so now I can split. So I have 3x and 3x is equal to 12 and negative 12. And so you divide by 3 on all ends. And so I get x equals 4 and x equals negative 4. So x equals plus or minus 4. I'm going to let you check that answer on your own.